All right, page 523, we're going to start by having you work just 3 problems similar to what you had at the bottom of your homework, numbers 19, 20, and 21. They're in the review section. So work those 3 radicals, reducing them down to simplest form. Take a look at those when we take a look at the homework here in just a few minutes. With numbers, factor them so that one of the 2 factors is rational. With letters, just ask yourself, how many times does this, the index, go into that, the exponent? Let's see how we did on these. We'll get to them in just a moment. Well, let's go and look at them now. We'll take a look at that classwork and then go into the homework. Number 19, the cube root of 48. How did you factor 48? Or could you just take the cube root of 48?
8 times 6.
Good. Factor to 8 times 6 because 48 is irrational. What did you get when you simplified it down?
2 times the cube root of 6.
Good. 2 times the cube root of 6, and Joshua, good as well. Number 20, Joshua, we don't have to factor anything because there's no numbers. So we just say, how many times is this going to that? What did you get?
X times the square root of x.
X times the square root of x. Excellent. Number 21, Josh, I'm going to stay with you here. The 4th root of 800 n to the 9th. Now, Joshua, we've got, if we flip back, some squares and square roots, right? We've got cubes and cube roots. We don't know a lot of fourths, do we? So let's think about some fourths real quick. 1 to the 4th, of course, is, but that never helps anybody, so forget it. 2 to the 4th.
16.
16. 3 to the 4th. 81. 4 to the 4th. First one, if you can call it out.
256.
256. All right. 5 to the 4th.
It's 125 times 5.
No.
525?
625. 625. Now, remember, the number in question here that we're trying to factor is an 800. Any of these look like they could fit in an 800.
Maybe it's 16.
Yeah, not this one. Nope, not that one, and definitely not that one. Our only hope is 16. So, let's see, can I divide it by 16? 16 into 80. 5. And that comes evenly. So yeah, 50. So we're going to factor this 800 into 16 times 50. Did you do that? No. Did you do that? Yes. So Lana got the 16 times 50. Josh has it now. And then, of course, we had this end of the 9th that was just sort of there. So that really was the hardest part, was figuring out which of my fourths should I use. Joshua will take the 4th root of the
16.
to get
2.
2. And for now, we'll just leave inside the radical
50 and into the 9.
the fourth root of the 50. Now, I'm not actually going to leave the end of the ninth. I was just taking care of the number. Now, let's take care of the letter and ask ourselves, how many times does this go into that? What should we write now?
N squared on the outside and N on the inside.
And there's our answer. Lana, did you have that? Great job. And then Josh, you've got it now. Questions on that? Don't like fourth roots. Square roots, no big deal. Cube roots, usually not a problem. You start getting to fourth, fifth, sixth, seventh, eighth roots. Oh man, that's too annoying. Let's go and take a look at the homework now. Numbers 1 through 11. They're at the bottom of page 523. And tell you what, let's go over the 9, 10, 11 because that's very similar to what we had on the classwork we just did. Lana, number 9, the fifth root of a to the 18th.
A cubed times the square root of a cubed.
Well, it wasn't a square root, it was a fifth root. So a cubed times the fifth root of a cubed. You want to make sure you don't forget your little index. Yeah, what would happen on a quiz if you forgot an index, Josh?
Oh, you get points.
Minus a point. That's just sad, isn't it? You know, get a 99 or a 98 on a quiz and it's just like, you know, it just galls you. And anyway, not trying to open any old wounds or anything. Poor Josh. Number 10, Josh, will be the square root of 48. Now, in the classwork, we had the cube root of 48. And Lana factored 8 times 6. Is that what we should factor here, 8 times 6? No, because it's not a cube root, it's a square root, and the number 8 doesn't do me any good. How did you factor your 48?
4 times 12.
4 times 12, so your answer?
2 times the square root of 12.
And I think this is somewhat analogous to taking something like 10 thirtieths and saying, ooh, that reduces to 2 sixths. I could divide out of 5. It does reduce to 2 sixths, doesn't it? But, thoughts on 2 sixths?
1/3.
You could go one more time, reduce it all the way down to a third, right? Thoughts on the square root of 12?
Oh, the 4 times 3.
You could actually go one step further and get what final answer. Looks like Lana also missed this.
4
times the square root of 3.
There we go. 4 times the square root of 3 because we get another 2 from this times the 2 that was already here to get 4 times the square root of 3. Or if you factored into 16 times 3, not that we memorized our 16 times tables or anything as kids, that would have gotten you an answer more directly. So again, moral of the story, once you get it down, check to see if you could go further. It's not wrong, it's just not finished. Does that make sense?
Mark off of that on the quiz.
Well, yes. For instance, if it was a 10-point quiz question, you got halfway, right?
So you count
So it would be 5 points instead of the full 10. Yeah. But I would give you the half credit for making it halfway, but yeah, you don't want -5, you want -0. 100 A plus sticker, the word perfect, and everything, but not the word do. We don't just perfect. That's it. All right. Let's see, number 11. Let's bounce over here to Lana, where we had the cube root of 800 x to the 9th. And Josh just factored an 800 for us, did 16 times 50. But that was for a fourth root. And 16 is a great fourth, but it's not a good cube. So, Lana, in the homework, how did you factor the 800? 8 times 100. Of course, don't lose the x to the 9th for now. So, what did you get for your answer?
10x times the square root of 8x.
Ooh, careful. It's not a 2. It's not a square root. 100 isn't my number.
Cube.
It's a cube root. 8 is my number, Lana. Can you take the cube root of 100? You take the square root of 100, but this is a cube root. I don't want the cube root of the 100. I want the cube root of the 8 to get 2 2. There we go. And we're actually going to leave the cube root of the 100, and there's actually not another cube in there, right? You think, well, maybe it's like the square root of 12. I can factor it further. Well, 8 doesn't go in, 27 doesn't go in, 64 doesn't go in, and 125 definitely doesn't go in. So, nope, that's all you can do for the factoring. 2 times the cube root of 100. And what about the letter, Lana?
X cubed?
And what left over?
Nothing.
Nothing. So this should have been our answer for number 11. 2x cubed times the cube root of 100. It's important to spot which index because that tells you which list. Am I looking at the squares? Or am I looking at the cubes? Or, heaven forbid, am I looking at the fourths? The fifths? Anyway, no. Hopefully we won't do that very often. Questions on this? Questions on this? Does it make sense now, though?
Yes.
All right. Now, yesterday we began looking at a new type of equation that used this whole square root thing, and new type of equation that didn't have one answer; it had two. What type of equation is going to have two answers, Joshua? Quadratic equations. That's what we began looking at yesterday. And I told you a quadratic equation can be easily spotted because it has something that no other equation we've worked so far has had. X squared in it. So you're looking at an equation and everything looks normal, and then you see an equation with an x squared. You're like, hey, that's a quadratic equation. That equation is going to get two answers. Now what we're looking at are called pure quadratics. When you think of something as pure, there's nothing mixed in that doesn't belong. For instance, pure water. Pure water.
You just took a sip.
So good. Backwash. Not pure. Just kidding. It's not really that. However, I have been known at times to, I've got 4 small children, and my son's, hey, Daddy, can I have some water? And, being a loving father, here, son, here, have some water. But if he hands me back the bottle and I see flotsam in the bottle, like, you know what, son? You can just keep the water. I'll make do without your... Yeah, well, I don't accept even my children.
I don't even share it with my siblings.
Yeah, probably safer that way. But anyway, but when there is backwash in my water, that is not pure. Quadratic means it's got the squared variable, the x squared. If there were something like a first power, that's like backwash. But if there's no first power, it's a pure quadratic. Pure quadratics are the easy ones. Now, next year in Algebra 1, I'll teach you how to solve what are called incomplete quadratic equations that are not pure quadratics. But for this year, it's 8th grade. You're still in junior high. We're just going to stick with the pure quadratics. And it's pretty easy to solve a pure quadratic. You solve it like an ordinary equation, except when you get the letter by itself, you're going to have to take, class, the square root because it's an x squared. So it's just like any other equation, except you have to take a square root at the end. And when you take the square root, it's important to remember there are actually 2 square roots of every number. One of them is positive. That's the principal root, but there is also a square root that is negative. And that's what we had to do on the homework 1 through 8. Number 1, you were given the equation a squared equals 81. Well, in an ordinary equation, you try to get the letter by itself, and it pretty much is except for the squared. So all you have to do is take the square root, Lana, and get
A equals positive negative 9.
A equals positive 9 and A equals negative 9, but I like the way Lana said it. A equals positive negative 9. Number 2, same thing, just take the square root of each side, and what do you get, Josh?
H equals positive negative 40.
H equals positive negative 40. Now, if you weren't sure about the square root of 1600, you could always factor it into 16 times 100, where the square root of 16 is 4, and the square root of 100 is 10, and that multiplies to get you 40. Positive negative 40. Now, on number 3, Lana, you can't just take the square root. You've got to get the s squared by itself first, which means you had to...
Subtracting.
Ooh, it's already being subtracted.
What did you say?
What do you have to do first on number 3 from the homework?
Well, I meant add.
Okay, there we go. Good. Add the
I
8
did that. I just said
to both sides to get s squared equals? over 3?
36.
36. And then you could take the square root, now that the s squared is all by itself, to get?
S equals positive negative 6.
Good. So you're going to isolate the squared variable, in this case the s squared, and once it's all alone, it's isolated, then we'll take the square root of both sides. Good job. Positive negative 6. Number 4. We can't just take the square root, Josh. What do we have to do first?
Divide out 12.
Divide out the 12 to get s squared again equals 16. Then you can take the square root to get
Positive negative 4.
s equals positive negative 4. Looking at number 5, Alana, the first thing you had to do?
Add 25.
Add 25 to get w squared equals 625. And then you had to take the square root. And I don't think that was on those pages, was it? So you had to kind of figure it out. What squared would give you 625?
25.
So your answers, plural, were?
Positive negative 25.
Positive negative 25. Way to stick with it. Did you also figure it out? Good job sticking with it. Even though it would, now, you knew it had to be bigger than 20 squared, right? Because on your paper, right, we knew 20 squared was 400. And so 625 is obviously quite a bit bigger. So what I might try is, well, what about 30 squared? But you figure out that's 900. Okay, that's way too big, right? So it's somewhere between 20 and 30. And it ends in a 5. Well, it's got to be 25. So there we go. That's a quicker way, perhaps, as opposed to, let me try 21. Nope. 22. Nope. 23. Nope. 24. Nope. 25. Hey, there it is. That method does work, but it's going to take you a while. Let's see, number 6, Joshua. You had to do 3 things in a particular order. First,
Subtract the 23.
subtract the 23 to get 2p squared equals 162. Then you had to
Divide out the 2.
divide out the 2 to get p squared equals 81. And then finally,
Take the square root of
take the square root to get
p equals positive negative 9.
p equals positive negative 9. Great job. Good to go. Looking at number 7, add the 20. Well, first you have to cube the 3, right? To simplify that to just an ordinary number, 27. Then add the 21. Then divide by 3. Then take the square root. Lana, your answers.
G equals positive negative 4.
G equals positive negative 4. We good to go, or do we need to see it worked? Good to go. Number 8. What do we do first, Josh?
You subtract the 1.
Good. The thing that is least attached to the z is that positive 1. So we just subtract from both sides to get 8. Then what did you have to do?
Multiply by 8.
Multiply the 8 because it's being divided. So you multiply, that'll get you the 64. And then finally,
Take the square root of both to get z equals positive negative 8.
z equals positive negative 8. Great job, Alana. Get the same answer. Questions at all on your pure quadratics? Turn back, if you would, to page 521. I want to look at another pure quadratic that it doesn't necessarily always work out as nicely and neatly and clean. You're probably telling yourself, like, this just feels too easy. It's got to get harder. I mean, we're in 8th grade, it's the end of the year. There's no way he's letting us off this easy.
No.
You're right, your gut is right. Look at the example problem here. We've got a 2a squared, positive 2, is equal to 2 times 501. I'm not sure why they felt they had to do that to you. Well, obviously the first thing we want to do is we don't like combinations. We just like to simplify wherever we can. And 2 times 501 is easily simplifiable, right? So 2 times 501, class, 1,002. Right?
Oh.
When you multiply by the 2 to get 2a squared plus 2 equals 1,002. And so now, Lana, we would need to start working on getting that a squared by itself.
Subtract the 2.
Subtract this 2 away from both sides. And that actually works out pretty nicely because 1,002 is like, why? So now it's just going to be a nice, easy 1,000. And still not ready to take the square root yet, Josh. We need to
Divide by 2.
divide away the 2. And that'll give me, of course, a squared is equal to 500. And we have a little problem here, don't we? We know 20 squared is 400. 30 squared, we discovered, was 900. 25 squared is 625. But there's not anything squared that gives 500. So because nothing squared equals 500, when we take the square root, it just means our answer isn't going to be a nice, easy number. We're going to have to factor our 500. But it ends in double zero. How should we factor the 500, class?
50 times.
How about 100 times 5?
I was
Anytime it ends in
thinking-
double
I was
zero,
thinking of that.
factor the 100, right? 100 times 5. Or I can take the square root of the
100.
to get,
10.
so our answer, notice, will be positive negative 10 times the square root of 5. We're still using the positive negative because we still have two roots, but these are irrational roots instead of rational roots like we were getting yesterday. Does that make sense? So we've been working on reducing radicals. We're not done. We're still doing them. We're just doing it at the tail end of pure quadratic equations. Turn the page to page 523. Page 523. And I want you to do numbers 13, 14, and 15 at the top of the page. 13, 14, and 15. Solve them like you normally would, but they may or may not work out rationally. You may have to reduce the radicals. All right, for sake of time, pencils down, even if you're not finished, and let's go and take a look at this. Now, number 13, really straightforward, Josh. What do we have to do?
Just like factor the.
Well, not yet.
Take the square root.
Take the square root of both sides. And the square root of u squared, u. But we can't take the square root of 75. We need to, but we can't, which means we have to factor it. So we're going to now factor that 75 into
5 times 25.
5 times 25? So 5 quarters is 75 cents?
No.
I'd love to have 75 cents from you.
25 times 3.
25 times 3, there we go. And so what should our answers be?
Positive, negative, 3 times the square root of 5. No,
Which
5 times the square root of 3.
There we go. We're taking the square root of the 25 to get 5, and we are leaving the 3 inside the radical. Did you get this answer, Lana? And then Josh, you had positive negative 5 square root of 5?
Yeah.
Just be careful in the factoring there. Lana, on the next one, we got to do a few things here. What first?
Subtract the,
Not yet.
well, distribute.
Right, let's distribute first. That's what we always would want to do in an equation to get.
2 squared positive 6 equals 206 positive 2 squared.
There we go. So distribute to get rid of the parentheses. And then, Lana, you noticed, well, I've got a q squared over here. I've got another q squared over there. That's a lot of q squares. That's too many. One of them's got to go. Which one do we always get rid of? The little one. Hi, Glenn. We always get rid of the little one. And and then which one's the little one, Lana? I know, you just walked in.
The 1 q squared.
The 1 q squared. How do I get rid of it?
Just cross it out.
Well, I don't just cross it out. I got to do something to get rid of it.
Subtract it.
Subtract it away. Now I can cross it out. But what did it do to one side? Do to the other side as well. So now what's my equation got?
Q squared positive 6 equals 106.
There we go. Where now I would need to,
Subtract the 6.
from both sides, right? What would do to one side, I have to do the other. To get q squared is equal to,
100.
and then I need to,
Take the square root of
and of course the square root of q squared is just
Q.
q. Can I take the square root of 100?
Yes.
Oh, so I get
Positive negative 10.
positive negative 10. And that time it did work out rational. That's happy. Doesn't always work out that way. Didn't last time, but it did here. Questions on this one? Yes, sir.
Where did the 6 come from?
Well, remember when you distribute,
Oh, yeah.
you should get a 2q squared positive 6. So maybe that initial distribution step messed us up there. Right?
Yeah.
Questions on that?
No.
All right, now Lana, it would be unfair to Josh. He had one he had to reduce. And you got one you didn't have to reduce. So in the interest of fairness, I'm going to come back to you on 15 and give you one that's going to have to be reduced. What do we need to do first?
Wait, is that 511?
Is it 511 or 4? Oh, it's a 511.
511.
I can't read. Okay, let's try 511. All right.
I
was just seeing if you were paying attention. Good job. All right, now what do we do?
Wait, and then you subtract the 25 from both sides.
Good. Subtract 25 from both sides to get k squared equals.
486.
And then we need to.
Take the square root of both.
And can you take the square root of 486? Well, maybe we just don't know, right? So we might try some numbers. Now we know it's got to be bigger than 20 squared, right? So maybe we try 21 squared, and well, that's 441. I try 22 squared, that's 484. And it just missed. If this had been a 27, we'd be in business. But we're not. So, Lana, I can't take that square root. I'm going to have to reduce it by factoring, right? So, now you were right when you said factor it. Let's see. 486. That's a really big number. I don't want to say, does 4 go in? Does 9 go in? Does 6? We're going to be here all day at that rate, right? So what I like to do with the big numbers, remember, is I like to say, well, what happens if I cut it in half? Maybe I'll get a big square. What is half of 286, Lana? Or 486?
243.
Is that one of our squares?
No.
No. We could go back and look it up on the table. So cutting it in half didn't work. Maybe we could try cutting it in 3 pieces. Divide it by 3. 3 goes into 4 with...
So 6. So 161.
Well, 3 goes into 6.
I mean 162.
Is that one of our squares? No, 169 is. Now remember, I said we're not going to use 4 because that is a square. Let's try 5. Wait a second. Can you divide that by 5? No. Maybe 6. Let's see. 6 would go into 48. 8 times with nothing left, right? Then 6 goes into 6.
1.
Now, could you have done it using the little numbers? Yeah, you could have gotten there, but it's quicker, I think, if you find the 81 times 6, because now, Lana, we can take the square root of the
81.
to get
9
times the,
square root of 6.
and
But you have to put the positive and negative sign.
good, and we don't forget the positive negative to show both solutions to the quadratic equation, and that should have been our answer. Positive negative 9 times the square root of 6. Questions on these 3. So just again, a little strategy with those big numbers. Try dividing by 2, 3, 5, 6, rather than 4, 9, 16, 25. Just think it'll get you to the 81 a little bit quicker. All right, do 16, 17, and 18 now. 16, 17, and 18. All right, check your answers to 16, 17, 18. Number 16, divide both sides by 2 to get the 80. Take the square root, just missed. 81, we'd have a 9 here, right? But it's not an 81, it's an 80. So I happen to see 16 times 5 because I'm the math teacher. So I got 4 times the square root of 5. If you didn't see that, hopefully at least saw 4 times 20, which would get you 2 squared of 20. And then maybe in the 20, you see the 4 times 5 to get 4 times the square root of 5 still. Did we get positive, negative 4 times the square root of 5 for our answer? Good. On the next one, you add the 4 to get 21, you divide away the 3 to get 7, you take the square root. Well, you can't factor a 7, it's prime. So you just leave it, positive, negative, square root of 7. You get that answer for number 17. Then on number 18, we're going to add the 12 to get 135, multiply the 3 since it was being divided to get r squared equals 405. Well, if it were 400, that'd be 20. But it wasn't. So now I happen to see 5 times 81. Maybe you saw 9 times 45. Maybe 9 and 45, you get 3 squared root of 45, and then saw 9 times 5 again. But doing it this way, positive, negative 9 times the square root of 5, our answer. Did we get that for 18? Excellent questions on these questions. All right, turn over to page 524. Page 524. And do number 12 through 17. Numbers 12 through 17. Page 524 at the top, numbers 12 through 17. Pure water is so good. Well, okay, pure with added minerals for enhanced flavor. of discord among the brethren and sisters.
It's all Friday.
What?
It's all Friday.
We'll find out.
Yeah, I don't.
Well, the challenge of next round since is well done. I said it's not going to be a mandatory exam. We just have.
Really?
I was like, that's a really big rabbit can. That's all.
Yeah,
Yeah.
it can't be.
For sake of time, let's go and stop where we're at here. You should have most of these done by now. The first few worked out evenly. That whole top row, 12, 13, 14. Check your answers. Positive, negative 5, positive negative 12, and positive negative 4. They just got GCS out of order. S should have been after that. But anyway, for S, G, and C, did you get those answers on 13, 12, 13, and 14? We come to number 15 here, and when you add the 5, you get 54. You can't take the square root of 54. 64, yes. 54, no. Did we factor 9 times 6 to get positive negative 3 times the square root of 6? Excellent. Then this next one was really annoying because we subtract the 16, we divide the 5, we get 120. And I start thinking through, I'm like, okay, I'm going to do this the easy way, right? Divide it by 2, nope. Divide it by 3, nope. Divide it by 5, no. I mean, I know there's a 4, but there's got to be something better than a 4. Nope. That's it. 4 times 30, get positive negative 2 times the square root of 30. Did we get that same answer? Questions on number 16? And then number 17, pretty straightforward. You add the 36 to get 80, multiply both sides by 10 to get 800. And I started to write 100 times 8. But then it dawned on me, wait, 400 would be 20 squared. 400 times 2. So positive negative 20 times the square root of 2 is the fully simplified answer. Now, if you did 100 times 8, you get 10 times the square root of 8, and then factor the 8 again into 4 times 2, but we're able to save myself the time there. Did we get that for 17? Or perhaps on the right track for 17 if we weren't quite finished?
Still, like, the way I did it, I still don't see how I would get. So first I did 4 times 2 over here.
And you did 4 times 50.
And
Then you did 50, 25 times 2, not 25 times 5.
oh wait, yeah, that's.
Yeah. And then right here
Then it
though,
would be.
well, but see here you had a 4 gives you a 2. This 4 gives you a 2, but you lost the 2 you started with. So that would have been a 4. And then times, so this would have been a 4 times the 5 would have given you the 20 times the square root of 2. Yeah.
So it would have taken me a long time.
Yeah, if you start with 4 times 200, it's a bad sign. It's going to take a while. Gonna take a while. Flip back, if you would now, to page 523. Just want to run through some quick questions with you. From the review, number 22 says, give the specific name for the type of triangle that fits each description. Bless you. You know we've got a final exam coming up, and I want to make sure we remember some of these things about triangles. What do we call any triangle with all angles less than 90 degrees?
Acute.
Good, an acute triangle. Letter B. Any triangle with no sides equal. Isosceles would have at least 2 sides equal. No sides equal.
Scalene.
Scalene. Very good. How about a triangle with a 90-degree angle in it?
Right.
Right triangle. Triangle with one angle greater than 90. An obtuse triangle. Good. Triangle with all sides equal. Equilateral. And if all the angles are equal, equiangular. And then what about a triangle with 2 or more sides equal? Isosceles. We mentioned that a moment ago. Look at number 23. We're not going to take the time to work this right now, but it says find the measure of the third angle of the triangles with the following given angles. Notice they give you 2 angles, 81 and 12, or 138 and 19, or 57 and 60. How would you find the third angle? Good. Remember that all 3 angles have to add up to 180, so you'll add them together, subtract from the 180. We'll take a look at those more tomorrow as we do a little bit of triangle review tomorrow at the start of the hour. No homework this evening. Have a wonderful rest of your day, and you are dismissed.